Okay.
Okay, so hi everyone. Welcome to the 115th session of the Stanford MedAI Group Exchange Sessions. This week we have Kaishuai Xu from Hong Kong Polytechnic University here with us to talk about his work on clinical process-aware medical dialogue systems. And Kaishuai is a third-year PhD student in the Department of Computing at the Hong Kong Polytechnic University, and he's supervised by Professor Wenjie Li. His research focuses on developing reliable and trustworthy medical applications. And his research interests also include medical dialogue systems, radiology report generation, and other applications that are powered by large language models. And Kaishuai, thanks so much for being here with us today, especially at this very early time for you. I guess before we start, do you have any preferences on how you'd like to take questions? Is it okay if we interrupt you, or do you prefer them at the end?
Interrupt is okay, I think.
Okay, perfect.
Yes.
So
Okay.
let's make this session as interactive as possible. And without further ado, let me hand it over to Kaishuai.
Okay. Thanks for the warm welcome. My name is Kaishuai. I will introduce my research work about the medical dialogue system. The topic is behave like a doctor, clinical process where medical dialogue systems. I will introduce the content following the outline. First, I will introduce the background of this medical dialogue system and several tasks and the definition of the dialogue system. Then I will introduce the challenge and our work to solve these challenges. I will introduce three works. First, telemedicine is actually a popular concept that emerged several years ago. However, in recent years, it attracted a significant attention after the outbreak of the COVID-19 pandemic, especially in China. Some rural areas, people cannot access the medical service immediately. I think it is almost the same in the US, right? It actually is a practice of delivering health-related services remotely. And one of the application of the telemedicine is medical dialogue systems. Now it has another name or another nickname, medical chatbot or medical agent. Especially agent is a popular word in the last year. And the system aims to provide health consultation, diagnosis, and prescription. For example, in the international platforms, the iClinic and the Chinese medical dialogue system platform, Chunyu Doctor, they all provide the health consultation, health diagnosis, and the prescription. And I focus on the task for the medical dialogue system is the medical dialogue generation, which is one of the tasks. It aims to generate natural, professional, and empathetic responses in each dialogue context. In other words, it meets the diverse needs of patients, not just diagnosis. It can help manage the chronic disease and other demand from the patients. The problem can be defined as response generation. We define medical dialogue as the U with a set of P and D. P represents the utterance from patient and D represents the utterance from doctors. And each utterance includes or contains several medical entities and imply different action or include other information from the utterances. And given the history of the dialogue, we aim to generate the T's doctor response DT. Here is an example. For example, it is a context of medical dialogue. The patient have some symptoms and he asks doctor for help. And after several turns of communication, our system aims to provide another response. For example, here D4. and it is the general framework or general format of the medical dialogue systems. The evaluation of the medical dialogue generation is for several perspectives. First, from the natural language generation matrix, the blue and the rouge, which is the measure for assessing the fluency, the similarity of two sentences. And another matrix that is specifically for the medical scenario of the disease or entity F1, which can assess the response accuracy. Accuracy is very important in the medicine scenario, since the wrong response is not allowed. It will cause severe situations. The other evaluation actually is from the real human, maybe from several doctors that assess the response quality from the given perspective. And with the popularity of the large language model, we include the LM evaluation. It is another, or is a new perspective to evaluate the response. We can design several difficult or complex framework to evaluate the response. The challenge of the medical dialogue generation is a lasting topic. Actually, is how to behave like a doctor. Several researchers in these years to solve this problem, solve these challenges. There are three directions to solve the challenge. The first is automatic diagnostic system. Actually, it is old topic or old task, maybe from the 1980s. The input is the symptoms or a series of symptoms, and its output is several disease or diagnosis. However, these systems cannot actually communicate with the patient. The interaction between the patient is the symptom. However, actually, patients has the difficulty to describe his real symptoms. It is a common scenario, right? And the second try is to construct a fluent response generator. Actually, in the natural language processing area, it is called another name, knowledge grounded response generator. Researchers use an external knowledge or to predict external entities or concepts to enhance the response. However, this response generator is only based on the natural progressing or only based on the response informatives, not from the medical accuracy or or other perspectives that related to the medicines. So it is not a real doctor, right? And the second direction is as popular in these years, in the last year. GPT and ChatGPT and Claude, they have the ability to solve some medical questions or solve some medicine exams. It is in high accuracy to solve the medicine problems. However, as we all know, we use the ChatGPT like a question and answering systems. It can solve any problems in one turn, not multi-turn. So actually, he wants to solve your problem or solve your ask questions, but he cannot be a doctor to follow the instruction of the medical knowledge and to diagnosis, to prescribe, to do some interactive communications. So from the perspective of the clinical communication, there's Calgary Cambridge guides to teach the clinical communication. It's emphasized one concept. Patients need to structure dialogue in a logical sequence. As you can see in this figure, a medical dialogue or a clinical communication generally follows several steps, or generally obeys these follow steps. First, initial session. It includes identifying the reasons for the consultation, or in other words, the reason why the patient come into the hospital, come to the doctors. Then the patient needs to gather information about the doctor needs to gather information about the patients, some biomedical perspectives, the patient's view of his symptoms or his situation, and some background information. And the several steps will follow the physical examination, explanation, and planning, and finally closing the session. So medical dialogue actually follows a quite structured sequence, and this sequence cannot be reflected by the available systems. Another perspective is from the evidence-based medicine. This evidence-based medicine actually is a rule, or actually is instructions that ask or require doctors to construct his decision or follow follow these rules. First is knowledge-based. Your decision or your behavior should be based on the medical knowledge, based on the case corpus, and etc. And another perspective is that your decision should be, or your decision is generally based on the experience, which contains a physician preference. This preference in here refers to the clinical expertise. An expert doctor or expert professionals can do different, or can behave differently compared with medical students or patients that's just after the graduation. So as we know, these three systems or three solutions cannot be a real doctor, and how clinical process is required. This clinical process refers to the sequence, the structure of the medical dialogue, the rules that you need to follow, which you have to incorporate into the clinical process. So here, our work aims to create organized and reliable and aligned medical dialogue systems that can take the clinical process into considerations. Now I will introduce three works of my research. The first one is medical dialogue generation via dual modeling, which is accepted as ACO 2023. This work aims to address the challenge that model the information flow in the medical dialogues. Here is the example. As you can see in this interaction between the doctor and the patient talks about his symptoms, and you can see the entities that is both. Oh, sorry. Okay. In these interactions, we can extract several entities. These entities follow the entire conversation and appears one by one. And another information is that the doctor actually will behave the actions in their utterances. For example, the first utterances, the doctor say, "Hello, I'm glad to answer your questions." And where exactly is the stomachache? Here, the doctor behaved two actions. One is chit chat. "Hello, I'm glad to answer you." And the other is inquiry. The doctor will inquire about the symptoms to gather information. So it is two kinds of information that's contained in the medical dialogue. In the previous work, studies always focus on these information. It is quite important. However, they fail to capture the transition of these informations, which is from the conversation sequence and the information interaction between these two informations. And it is what we will solve this challenge. We create a dual flow, which is entity flow and act flow. And then we use these two floors to understand the dialogue history and to predict more information that will be included in the responses. Here is a method. The dual flow modeling modular will predict the acts and the entities, and these entities and acts will be incorporated into the response generation to generate another or generate the following responses. Here is the dual flow modeling module. We actually use a 2R model. Actually, this work is before this work is done at 2022. So at that time, LLM is a popular solution to solve the problem. We use 2R models. The one is applied in the act flow modeling, and the other is applied into the entity flow modeling. And for the entity flow modeling, each input is encoded by a graph model. And the output of these two flows is then sent to the predictor and the selector to predict the actions and the entities. And these two information is then sent to the NLG to predict the next responses. Here we design another module named interviewer. This module will incorporate with it. This module will capture the attention from each other to learn the information from each other. For example, here, the action, precaution, and task will learn the information from the entities. Actually, these entities can reflect the topic or the information for the next response. So this module can help to capture these informations. Then the response generation modular will incorporate the predicted action and entities with a fusion gate to generate the next response. Here's the results. We actually apply the model on two data sets. The one is MedDG data set and the another is COMET data set. For the MedDG data sets, our model achieves great accuracy in the blue and rouge. These two metrics indicate that our overall response quality improves compared with the baseline models. Since our work is at quite early stage and there's not many strong baseline at the time, so we use the GPT-2 and BART, which is all the basic models. Another measurement is the entity F1. The accuracy of the entity F1 indicates that our response accuracy increased a lot. It is a quite important measurement for the medical responses. The similar improvement can be also seen in the COMET dataset. Our model outperforms the baseline models actually a lot, since we are the first one to incorporate dialogue actions into the medical response generation. Dialogue action is quite important indicator for the communications that can help to format the response structure. Yes. Here's a case. We can see in the context, patient and doctor conduct several interactions, and the last one is our responses. The first is select the entities. We select the gastritis and several macro entities, and we predict actions, diagnosis, prescription, and test, which means the doctor needs to make a diagnosis, or the doctor needs to indicate a specific disease the patient may have, and he needs to prescribe our medicines and require another medical test to check some information. And here is the response that generated by our models. We accurately capture the important information that predicted by the differential modeling module.
Hi, Kaishuai, I have a question here. So,
yes, okay.
The types of entities, diagnosis, prescription, like how did you decide what type of entities you would include? Right, are you using some ontology to figure out what is an entity and what's not an entity?
Okay, actually, macro entities include several types we extracted from the knowledge graph. The types include the disease, several, maybe 2,000 disease that was included in our external knowledge graph.
In these,
and yes, the test.
And did you create the knowledge graph, or was it already?
No. I adopt available knowledge graph.
Oh, okay.
Yes.
Okay.
Yes.
And then again, like the in the ACT predictor, how many possible actions are there? Because I can see there is the diagnosis, there's the prescription, but what happens when through all of the dialogue, when the
actually
the model is just trying to gather information?
It is actually 7 dialogue acts.
7 acts
included. That is quite related, or that is the medical specific dialogue actions. For example, inquire about symptoms, to check, precaution, test, and diagnosis. Yes.
Okay.
It's totally 7. Yes.
And these, again, 7 actions you provided, like there is no standard set of actions that are possible. You decided that they need to be 7.
Yes,
right?
yes. I decided. Yes. I actually select these dialogue actions which capture maybe 90% of you all responses. Yes.
Okay, that makes sense. Thank you very much.
Yes. Okay. And then the second work aims to construct differential diagnosis that's on the methodology generation. Here is a challenge: how to construct a robust differential diagnosis. The motivation is that actually before this study, researchers try to generate responses just by a language model without another explicit differential diagnosis model or differential diagnosis components. Or they will use entity prediction to enhance the response. However, it is not diagnosis. It is not based on the symptom, based on the available symptom, or based on the available information contained in the dialogue history. So a proper diagnosis is crucial, as it establishes the foundation for the future consultations. a doctor will interact with the patients, although he will not explicitly say, oh, you have blah, blah disease, but he has an implicit decision about the patient's symptoms or patient situations. So our medical assistants or medical dialogue systems can help the doctor. And the premise is that the clinicians, the doctor need to understand, or they have to understand the diagnosis rationale behind the response and agree with it. Then he will adopt or he will acquire our responses from the systems. So here we aim to construct a robust differential diagnosis that can support our response generation. The method we use is a series or yes, it's a series from the Mason's area. The clinicians typically employ both intuitive and analytic reasoning to formulate a differential diagnosis. Actually, it is project that is work in progress. So I will introduce some preliminary methods and results. Here we first design an intuitive association modular. This modular will use the dialogue history to extract the SOAP segments. SOAP is a commonly recognized format that document patient information. For example, it includes subjective information, objective information, assessment, and plan. We use LLM to extract this information, and this information is used to retrieve from the patient cases corpus and the disease documents. This retrieve can quickly or immediately generate a preliminary diagnosis list. And then we use the preliminary diagnosis set and use a DDX analyzer to refine the diagnosis set. Here we incorporate an external knowledge graph. This graph combined with the SOAP segments to predict the affected systems, affected organs, and the possible disease. These three classification targets will actually achieve a collaborative filtering effect that we can select a disease that is based on the affected system and affected organs, which is the analytic refinement. Finally, we adopt the patient cases and disease documents that was from the diagnosed disease and incorporate with the dialogue history to predict the response plus the dialogue actions. Here we use LLM. Since LLM has the capability to follow instructions, so we directly use the LLM to we fine-tune on LLM to generate the dialogue act and the response. Here's the case, preliminary case of our model. The left one is the dialogue history and some baseline responses. The right one is our diagnosis and the entities that supports the diagnosis. We create a diagnosis of a differential diagnosis of 4 diseases, and these system and organs that support the 4 diseases. Based on these diagnoses, we generate our responses. Actually, we are the only ones that can accurately predict the disease. As I marking these responses with explicit diagnosis, plus these entities support the diagnosis. Assisted entity means the system and the organs. Such a response is able to help the doctor to understand why the system responds like that. And the doctor will assess the reliability of the responses, and they will maybe adopt it or just omit it, which I think is the implementation or reliable solutions that the system can be adopted in the real application. Okay, then the third work is about the reasoning, about the doctor reasoning capabilities. Here the topic is reasoning like a doctor, improving dialogue system view diagnostic reasoning process alignment. This work aims to address the challenge that how to reason like a real doctor. Here's an example to describe why this is a very important challenge. The left is context. In this context, the patient displays the symptom or displays some situation with a bigger probability of the IBS. For example, these findings support the disease, and these findings oppose the colitis. However, for a real doctor, they will consider the colitis in the following responses rather than the IBS, which is in high probability. A general LLM will use the IBS, which is a higher probability. There's a gap between the real doctor and the LLM or general LLM or medical LLM. This is in my paper recognized as the clinician preferences, which means the doctor has their preferences to consider the situation in the following responses. Here he will consider the colitis in the following responses instead of the IBS, although the IBS is in the higher probability. So previous studies overly focus on the outcome of the clinician reasoning process. They focus on the responses. They focus on the extracted entities while ignoring their internal thought process of the doctors. Besides, it's failed to align with the clinician preferences, which is very important since doctors have their experience, and this experience will indicate clinician preferences, and these preferences is a great or strong indicator to reflect the capability, to reflect the expertise of a doctor. To construct or to align with clinical preference, we construct a thought process corpus we leverage by the LLM. Here is an example of thought process. The left one is the context, and the right is the thought process generated by the LLM. The prompts was constructed by the context and the real doctor response. For example, we import the context and the true doctor response. Have you done any cleaning today or been exposed to dust mites? And then we ask the LLM to generate the possible thought process why the doctor will say like that. We actually ask the LLM to respond like a chain of thoughts process. We actually collected thought process from two data sets, leveraged by two data sets, and for each data set, we have average 4 steps of the chain of thought, which is also the thought process. And each data set has the The first one has the 122,000 soul process, and the second data set has the 285,000 soul processes. Then we will construct a model or construct a framework to reason like a real doctor. We actually adopt some commonly recognized doctor rules or doctor behaviors to construct our framework. The first is diagnosis analysis, just similar to the previous work. Here we use abductive reasoning and deductive reasoning to refer to the two steps or two components, two operations in the diagnosis analysis. The first one is abductive reasoning. Here we use the clinical findings to retrieve the disease, and then we leverage the LLM to filter out disease that is not relevant to the patient conditions. And here we actually achieve affirmative operations for the diseases, which means we actually choose which disease can support the patient situation. And then choose the deductive reasoner, we actually achieve a filtering or achieve a post analysis of the available disease. Here, we will prompt the LLM that analyze if the new findings support, oppose, or irrelevant to the possible disease. As we know, medical dialogues contain several redundant informations that especially said by the patients. They will include some personal information that is not relevant to the diagnosis. So here the deductive reasoning will exclude these informations and analyze the relation between the available disease. Through this reasoning process, we construct the diagnosis memory. The first one is the first turn, second turn, and until the T's turn. It includes the findings and the relation between the finding and the disease. Then we turn to the soul alignment, which is the most important part in our framework. Given the diagnosis results, actually is the several disease, we use ranker to adjust the order of the disease that will be considered in the following responses. And then we choose the top 3 disease and incorporate into the LLM to generate the soul process and the responses. Here we actually fine-tune a large language models to generate the soul process, and the response follows the prompt instructions. Here are the results. Our framework names emulation. Actually, it behaves quite incredible in the NCF1 and the Roche matrix. Although it indicates a decrease in the blue matrix, actually it is because our fine-tuning is adopt the LoRa training, and only limited parameter will be changed, and it cannot change the overall response pattern of the log jungle models. So actually, it is one of the reasons that the blue matrix is not very good. But the Roche and the H1 increase a lot. That represent our work can actually behave better, much better than the baseline models. We also apply a human evaluation to compare our model with the baseline models. Here we compare with the DAISC MedLM. Actually, it is a medical it is IOM that is functioning on the medical materials, and the DFML is our previous models. We asked the 3 doctors to evaluate the responses on 3 aspects. First is knowledge accuracy, which is quite important as the hallucination problems of the EOM is quite obvious. So knowledge accuracy is an important indicator. The second one is consistency, which means if the response is consistent with the context. And the third matrix is specificity. This matrix is quite important for the LLM, since LLM can generate a complicated or complex responses that include a lot of things. Actually, you can include all things, then the doctor will respond. Such kind of responses are not very specific for the patients, and the patient will feel confused about these responses. So we ask the doctors to evaluate the response on the specificity. Actually, our model behaves better than the baseline model in these 3 aspects. Since we conduct a diagnosis analysis in the first components, we calculate the diagnosis accuracy and compare with the GPT-4. Surprisingly, our model can achieve better diagnosis results than the GPT-4. Here, with alignment is the final accuracy of our model, and it's explicitly significantly outperforms than the GPT-4 diagnosis. Here is the case. You can see the above one is context. We include the clinical analysis. Here, the analysis includes the relationship between the findings and the diagnosis. For example, here, diagnosis with gastro a year ago, suppose this disease GFD disease, and the test results were negative, oppose the results. And here's the generated thought processes. Actually, I think it is quite a good thought processes that actually help me to understand the responses. It includes 5 steps, and the response is here. We extracted from the thought processes. The response is that you could consider a gastroscopy to check, pay attention to your diet in the meantime. It is quite very similar to the ground truth responses. Another case is the CARMAP dataset. We also display the thought process as
Sorry, Drew, I think I missed that, but how you're evaluating the thought process?
Oh, okay. You mean how to evaluate the thought process, right?
Yeah, yes.
Yes, actually, we asked 3 doctors to evaluate the knowledge accuracy, the influence of the thought processes, and it is including my paper. Sorry, I missed these parts.
Okay, so you are actually doing manual validation for the thought process.
Yes. All these data sets and the evaluation are manually.
Okay, got it. Because I personally believe like the thought process, since you are doing a lot of like string generation with the sentence, but actually
Yes.
like you don't need the grammatical correction of the thought process, right? Because thought process is more like a chain of thought kind of thing, like point by point.
Yes.
So maybe it's
but
go ahead.
since we import the context and response and ask the model to align with the response, he can follow the pseudo logic in the thought process or the possible thought processes. I think it is also called a possible thought process, not actually real thought processes. Yes.
Okay. Okay.
Yes.
Okay. Because I think you can also, I don't know if you try that, because you can also generate the thought process more like a logic, right? Like more like a logic-based paradigm. I'm pretty sure that.
Yeah. Yes. Yes, you're right. But logic is too strict, right? Since the medical communications include several redundant information or several useless information. I think. Yeah, if you have ever tried to communicate with the doctor, you will say a lot to the doctor, since you actually you don't know what you provide is important or not, right? So
yeah, that is okay for the dialogue generation,
yes,
right? But for the
yes,
thought
yes,
process,
yes.
when you're actually evaluating the model generated response to a thought process, then I think probably it's better to represent it more mathematically using logic or something like that, rather than going through the sentence, right?
Yes, yes. I think the difficulty is that it's hard to define this logic,
Okay.
as there's no explicit instructions to
Generate the logic,
define
right?
it. Yes, yes, yes.
Okay. And do you have any like constraint on how many steps in the thought process, or how many sentences in the thought process the model can generate, or it's like more open-ended?
Oh, I set the maximum steps, maybe the 6.
Okay.
I think the doctor will review the previous conversation, but it will not. I mean, it will not consider that much complicated, I think.
Okay.
So the maximum is 6 and the minimum is 1, actually. Since, for example, the first doctor response is actually it is only a chit chat. You don't need to think about.
Right.
Yes.
Okay.
May I follow up with a question on the same direction?
Yes. Okay. Yes.
Your thought process can be evaluated by you or medical doctor?
Medical doctors, but not by me.
Okay, so how many medical doctors evaluate the thought process? Generally,
Actually, I asked 3 medical students, which has learned the internal medicines.
so their thought process, I mean the 3 medical students' thought process are the same.
No.
Or they are different.
No. I don't ask them to judge if the thought process is right. I only ask them to check if the knowledge included in the thought process. For example, in the first step, for example, in the first sentence here, this sentence, if the sentence includes the wrong knowledge or the wrong logic, it can be checked, since it's not about the logic of the thought processes. Yes.
Okay,
Since
you only check
yes.
the knowledge or fact are correct.
Yes,
You
yes.
do not check
Yes.
the logicals among the steps.
Yes. I think I said it is possible thought processes. Actually, it is not a real thought processes. We prompt the model to with the possible, or we ask the model to generate the possible thought process. Will help to generate the responses. So
I have a question along this line as well. So
yes.
for you can hear me, right?
Yes, of course.
Okay. So say, for example, a model has like 4 or 5 sentences that it has generated during the thought process. And in between, say after the knowledge is coherent till for the sentences 1 and 2, and after that it switches. How are you rating that kind of a thought process? Like coherent or correct? Say, for example, a doctor sees that the thought process is correct till the first 2 or 3 steps. And then after that, for the 4th and the 5th step, the model is like kind of hallucinating. How are they going to rate that? Are you using a Likert scale like 1 to 5, or you're using like a 0-1 matrix? Like, did the doctor, like, did the medical students encounter any such cases? Because a large language model might switch, right, in between. So I'm just curious.
Actually, we don't ask them to assess quite in detail. Actually, the standard is that if the thought process incorporates the wrong knowledge or incorporates the wrong implication, yes, right. Yes, if as you said, if the thought process is right at the first 2 steps and wrong in 3 or 4 steps, then the thought process is wrong.
Okay.
Yes.
So your thought process
Okay,
may
sorry.
not really explain your diagnosis, may not explain how you reach your diagnosis.
Yes.
So I can include garbage in front of all the thought process, anything as long as correct, but you regard as correct, but nothing to do with the diagnosis, nothing to do with the decision made by the decision made your system. Is that right?
Yes. Since we incorporate explicit diagnosis in the 2 reasoners, and the thought process actually is to think based on the diagnosis results. Actually, yes. So we have the basic diagnosis results, and these results will be incorporated into the thought process generation. So the thought process will not in outlier way or in that move far from to the diagnosis results, I think.
Okay, so do you have any evaluation to make sure the steps thought process really align with current medical knowledge? Not only individuals correct, but the steps are correct.
It is not actually. Since actually it is maybe the future direction for future research, since this system is already much complicated. So actually it is a new topic we can further explore, I think.
Okay, thank you.
I have a few more questions. So I just wanted to ask, like, when you are generating a set of it. Yeah, Amara, can you switch off your mute your mic, please? Yeah, sorry, I'm sitting right beside Amara, so my voice is getting.
Okay.
Yeah. So when you're generating the responses, say for example, you are giving like a multi-turn conversation, and you're generating a single response to that, like say 4 or 5 patient-doctor conversation, and then you're generating one single response, right? Like, I just wanted to ask you.
Yes.
Okay. And a few more things was, are you focusing on only diagnosis of a conversation, like only diagnosis of a medical condition? Like there can be some things like, consultation or something like a mental health kind of a conversation. I was just curious, like, are you focusing only on conversations that are diagnosis specific?
Actually, this research work actually focus on the diagnosis, but the data set includes the medical consultations.
Yeah. Okay. So you are just focusing.
Since in my perspective that the responses, no matter consultations or no matter prescriptions, you have to generate a response based on a robust diagnosis. So diagnosis is necessary, and you have to create one. And the available or the left part, maybe consultation or a prescription, is not my focus in this research work.
Okay.
Yes.
And the third
yes, but
question.
the data set do include this one. Yes.
Okay. And the third question was, are there any specific diseases that you were focusing on? Because that also kind of goes into the expertise of the doctors, that your doctors or medical students that you were kind of asking for rating your conversation. So I was just curious.
Actually, it is not. Actually, since our objective of the system, medical dialogue systems, or objective of the research of the medical dialogue system is to create a medical system that can assist the community doctors. Actually, we do not require the systems to deeply incorporate with the expert or professional, or professionalist doctors in one department or like that. Actually, it is a general instant immediate assistance that can help you, for example, make sure you what you're suffering from, and then you can go to the hospital.
Okay. And I was just
sorry, Abhisha, just one related question for that. So, but whenever you show some example, it seems that they are very focused on the gastrointestinal part. So I don't know.
Yes,
like
this data set focus on the gastro.
Okay.
Yes,
So you validated on a
and
data set that is focused on the gastrointestinal, right? But you didn't have a limitation.
Limitation of what?
The limitation of the what disease that Abhisha was asking you, right? Like what disease, or if you have a set of disease that you are particularly targeting.
No.
The data set that you validated, that was gastrointestinal. That's why all your examples are kind of close to gastrointestinal. Okay.
Yes. Let me introduce the two data sets further. The MDG data sets mainly focus on one department, which means gastritis. And the COMET data sets actually include 100 departments. It is quite a wide range data set. And since we use the external knowledge graphs, this graph includes 5,000 diseases. And these operations, these reasoners do not require the retraining of the available system. So it can handle the rare disease or disease that are not available in the data set. Yes.
Okay.
So to your case, MedGD you just presented. Can you go back the example you gave just a few minutes ago?
Which slides? Sorry.
I think the previous slides. Can you just go previous slides? Previous again. I don't know. So you have the title called case : MedGD. MedDG, yes. Your title of your slides.
Case colon. Oh, case colon MedDG data set. You mean this one?
No, probably next. Go next. It's a text. It's largely text, and gives the context and your diagnosis, your sort. Yeah, this one. Okay.
Yes. Okay.
I'd like to know what's given by the data set. What's generated by your system?
The data set only includes this one, the context.
So
given medical dialogue as follows. Others are all generated by our systems. The clinical findings actually is extracted by pre-trained LLM. Yes.
So this is all you get, and use this and generate all the rest.
Yes.
Okay. Thank you.
So I have one small question. When you refer LLM, so is it a fine-tuned on medical data set, or which LLM you are referring?
Oh, I use the QWEN, as you see. Since our data sets includes the Chinese dialogues. So we use LLM, the open source LLM that was friendly to the Chinese languages, which is QWEN7B. Actually, it is a popular open source LLM, even in the English language or in other languages. Yes.
Okay.
Which behave quite good in multiple languages.
So it is pre-trained on medical data set.
It is not specifically trained on the medical data set. I think it is a general LLM, open source LLM, and in our experiments, we only apply the available data set to fine-tune the models.
Oh,
Yes.
okay. So why do you not take the medical LLM, MedLLM from Google?
Actually, it is a good question. Yes, it is a good question. Actually, it is a commonly recognized concept that fine-tuning LLM to a domain-specific or a specialized LLM will interrupt, will decrease the capability of the reasoning ability or the capability of the instruction following ability. So if I use a medical LLM, I think some capability will be decreased, and I cannot use this model to accurately follow the instructions. So I choose a general LLM. Yes.
Understood.
And a lot of medical LLM is training by LoRa. I don't think such models can further training and fit to my data set.
Understood. Thank you.
Yes. Yes.
Great. I think that was a great talk, Kaishuai. Thanks so much. And thanks everyone for a great discussion section as well. I guess if there are more questions, you can always reach out to us or reach out to Kaishuai directly.
Okay. I have the conclusion slides.
Oh, okay, sure.
Okay. I will quickly finish this slide. Our study actually aims to construct an organized, reliable, and aligned macrodata systems. And there are several takeaways. The first one is, under this area of LLM, actually more work should be done to align a medical systems or chatbot agent or other LLMs with a real doctor. I mean, alignment is very important, not just thought process. Actually, it is possible or a pseudo thought process. Maybe you can align with another perspective. I think although the LLM is capable to do a lot of reasoning work, but his behavior is not aligned with a real doctor or aligned with other specialized or professionals. So it is a new perspective or a quite popular perspective, I think. The third one is, doctors are not just QA assistants. QA means question answering, and the communication between doctor and patients are a combination of knowledge, experience, and skills. Here I emphasize this experience and skills. The skill actually is indication of the alignment, I think, or the indication of the behaviors. Also the experiments. So actually, former researchers will focus on the knowledge alone, since they can create a knowledge-grounded model and adopt it to generate reasonable responses. However, under the area of LLM, actually we can move forward to a real doctor, which can incorporate experience and skills. Yes, okay.
I still ask some questions or too late?
Yes, okay. Yes.
And you mentioned the doctor experience, and you basically say their preference for the doctor. That also means different doctors may have different preferences. How good
Yes, it's a good question. Yes.
how are you going to incorporate this kind of wherever? The preferences may be wrong actually for some. So how you can
Yes.
include it?
Yes, actually, it is a big weakness of the available medical diagnostic research. I think, include me, since our research is based on the public data set. Actually, this data set is not very good. So, how to define the doctor with rich experience or with rich or with commonly recognized preference? Actually, I think it is available commonly recognized preference. For example, in the certain or particular scenario or situation, the clinician is recommended to follow some rules or follow some behaviors. Since each doctors will under the clinician education, and they will be supervised by his mentors, and these mentors will have similar experience or similar preferences, I think. So the next step,
you try to say follow the guidelines.
Yes, I think
guidelines, yes. There are no individual preferences at all. So preferences again.
Yeah, there's a preference, I think. It's the guideline is the guideline, and preference is the preference, I think. But the weakness now is that we don't have such high quality data sets to adopt it to learn the preferences. I think we have tried.
You include the preferences, individual preferences. Then could lead
apologies for interrupting, but perhaps we can take this discussion.
Okay, we can talk about it later. But my point is how you do it. It maybe give you biases again.
Yes.
Okay, I'm done.
Okay, thank you. Thank you. Your question.
Awesome. Thanks so much, Kaishuai. Sorry, I didn't realize you hadn't presented your conclusion slide earlier. So let's give our speaker a good round of applause for presenting today. And especially, I know that's super early in Hong Kong as well. And I think the discussion was great and well participated from everybody. We'll have the YouTube video up later today, and then you can ask more questions. And I know there's a lot of discussions going on, so I'm sure Kaishuai would be happy to answer your questions later. We will not be meeting next week since it's the Memorial Day in the United States, so we'll be meeting the following week, but hope everybody can join afterwards. So thanks again, Kaishuai, and yeah, great talk as well.
Thanks for your questions.
Thank you so much. Really good talk.